In this video, we're going to look at some of the things that you can do. Well, we're going to address this particular problem dealing with lines and points in space in 3 dimensions here. So the first one, it says, for this one, it says from the foot of the perpendicular from this point, 1, 4, 4, to the line, and then they give it to us in parametric form. Okay, so what we find to be, here's how they gave it to us. They said this is x is equal to 2t minus 1. They said that y was equal to 2 minus t, and they said that z is equal to 3t. Now, in just a second, before we even understand the problem, let me tell you that it's easier. That's parametric form. It's a whole lot easier to work with things in vector form. Okay, so if you remember, in this one, our variable is t. What we have here when we write the equation of a line is we've got a position vector. We have to get to a point on the line, from the origin to a point on the line, and then we have to move up and down the line. So this is the direction vector. So this becomes the position vector, and this becomes the direction vector of the line. And so when we look back over here, this is 2t, so the 2 goes here, that negative 1 is part of the position. This one, the t would be negative 1, and it's negative 1 times t goes in the direction vector. This 2 is the position vector. This one, it's 3 times t, and there's nothing here for the position vector. Okay, so now we need to talk about what in the world do they mean by this problem. So here we've got some line in space, and then some random point for one. Well, it's not random. They told it to us. And they're saying find the foot of the perpendicular from that point to that line. So what they want us to do is to say, okay, well, what would be the point? What are the coordinates of the point right here where I can get from that point to the line in a way that, well, the shortest way possible, and it's perpendicular to that. So then say, what's the foot of the perpendicular? What's the point on the line that makes a perpendicular vector, a perpendicular segment, a perpendicular line from that other point? Hopefully that's somewhat clear. Okay, so if you remember, we know that we have perpendicular vectors if the dot product is 0. Okay, so what we want to do is we want to figure out, well, my direction vector, which was 2, negative 1, 3, dotted with this direction vector needs to equal 0. Well, so then the trick is to figure out, well, what's this direction vector? And what we need to do here is consider the fact that any point on this line can be found by plugging in a t value into the equation of the line. So, for example, if t is 0, say when t equals 0, we have the point, well, this is all gone, and we just have the point negative 1 to 0. That's a point on our line. Okay, say when t equals negative 1. When I plug in negative 1, I'd have negative 1 minus 2, I'd have the point negative 3. Negative 1 times negative 1 is 2, plus 2 is 4, and that would give us 3. So what we have is that we can plug in different random values of t to find different points on this line. So the general term of a point on this line comes from this right here, or we can come back to the parametric equation. So the x-coordinate is 2t minus 1, the y-coordinate is 2 minus t, and the z-coordinate is 3t. And that's a random point on our line. We can plug in any value of t to find any particular point on that line. So now we need the vector. Well, we have a direction vector, and we need this vector right here. And to be honest with you, if you remember from our unit circle, the unit circle never goes away. I hope you remember it. Cosine, so here's 90 degrees. Cosine of 90 is equal to 0, and also cosine of 270 is equal to 0. Those are degrees. Okay, so we could do these vectors that are coming here and talk about this angle between them, or if I turned one of them this way, like instead of going away from the line, I came towards the line, then that could mean that I'm doing 270, but in any case, the lines would be perpendicular either with 90 or 270 degrees. Okay, so we need to find the vector going from here to here, or you could say from here to here. Let's do, so we've got, let me use color. We've got this. 1, 4, 4, and then we're going to subtract this point here, minus, well, 2t minus 1, minus 2 minus t, and minus 3t. I may have done that differently in class. I think I did the vector from here to here, but same difference. It'll all work out the same. Okay, so when I clean this up, this becomes the vector, well, it's a positive 1 plus 1 is 2 minus 2t. This is a 2 plus t. And this is a 4 minus 3t. Write it however you want. And now I need to take that vector and dot it with this vector and set them equal to 0 to figure out the t value. Basically what that's saying is at what time, at what t value at what time is, did we find that point where it's perpendicular, where that line is perpendicular to the original line? Yeah, these are fun. I'm serious, I do like them. Okay, and that's dotted with this 2, negative 1, 3. And we need to set that equal to 0. So I have 4 minus 4t minus 2 minus t plus 12 minus 9t equals 0. Did I do that correctly? This is negative 14t. And then what do I have? 2 plus, that's plus 14. Oh, that's convenient. So I have negative 14t equals negative 14. Therefore, t is equal to 1. So at t equals 1, we're at this coordinate right here. So when I plug in t equals 1, I get the point, what is that? 1, 2 minus 1 is 1, and 3. And so the foot of the perpendicular is the point 1, 1, 3.